Hello, and welcome to Astronomy 100. In the last video, we talked about how telescopes are used to gather the light that comes from our universe, from the stars and the other objects, and how that light comes to a focus at the end of the telescope so that we can see the objects of our universe. In this video, what we're going to do is talk about how the light is recorded and then, of course, analyzed. So the two topics we're going to address, the first one is how do we record the light that comes through the telescope, and then the second one is how do we analyze that recorded light. The picture that you see here on the right, this is the back end of a telescope. This is sometimes called the business end of a telescope or the working end of the telescope. You can't see it very well, but this is the opening of the telescope up at the top. The light comes through, bounces off of the mirror, and then eventually comes through the back end of the telescope where there's an opening. It's at this point that you would normally put your eye, but in the modern world, we put equipment instead of your eye. And the reason is because the variety of equipment that an astronomer uses is much more sensitive than the human eye, and it's able to make recordings of what we see through the telescope. Now, the first challenge that an astronomer has is the ability to make a permanent record of what you see. And so this falls into a category of what we call direct imaging. In other words, this is how we take pictures of things. In the old days, before photography, when the astronomer would look through the telescope, he or she would have to just simply draw a picture of what they're seeing because there was no photography to make a permanent image. Today, what we do is we use cameras to make a permanent image of what we see. In the early part of the 20th century, really the latter part of the 19th century as well, photography was done by using what are called photographic plates. These are plates of glass where the photographic emulsion or the sensitive chemicals are placed on the glass, and then the glass plate is slid into the holder at the end of the telescope, and then over the course of the night the shutter is opened and the image is recorded on the glass plate. In this example that you can see right here, it's a negative, but you can see an example of a galaxy that's been photographed by the telescope. So in today's world, though, we still take direct images, but there are some problems with the original glass plates that were used. This picture on the left is me, this is yours truly, sitting down examining a glass plate that was photographed back in the 1980s. And this is Jean Mueller. She's the one that actually took the photograph that is on this plate here. The glass plates, again, are just very, very normal plates of glass that have emulsion on the surface. And then, of course, the light shines onto the glass plate, and over a period of time, it's recorded as an image. It's very much like film, but the difference is that celluloid film is actually a bendable plastic type material. But before the invention of celluloid film, it was actually photographic glass plates that were used. Now, there are some advantages and disadvantages to glass plates. For instance, one of the biggest advantages is that a photographic plate actually has very, very high resolution. You have the ability to take a very, very sharp image of what you're seeing through the telescope. The small grains that make up the photographic emulsion are very small, and of course they can create a very high resolution image. But one of the series of problems that goes with photographic plates is that the sensitivity of the photographic emulsion is actually quite low. What that means is when the light passes through the telescope and then lands on the plate where you're going to record the image, it takes a long period of time for that image to get recorded because the chemicals are not very sensitive to light. It may take you hours to take one picture of one galaxy, let's say. So the sensitivity of photographic plates is actually quite low. Then there's the problem of processing. In the old days, especially with photographic plates, you had to take the plate into a dark room and you had to use the various chemicals needed to turn it into an image. It's time consuming, it's messy, and nobody really wants to do it anymore. And the other problem is it's hard to make copies. If you want to make a copy of your image, you had to re-expose your image onto another plate and then do all of the processing that goes with it. The final problem is the data is what we call analog. What that means is you get a picture of what you are seeing, but if you want to examine that picture with all of the powers of what computers can do these days, you have to scan the image to make a digital version of the picture so that the computer can now process it. So photographic plates are really not the type of plates that we want to use these days. Instead, we use electronic chips. And what an electronic chip does is a very similar thing. You expose the image on the electronic chip. But the difference is that an electronic chip is very, very sensitive. The amount of light that hits the chip gets recorded quite well. The sensitivity is in the high 90%. So essentially almost all the light that hits the chip is recorded. The data is digital. You can then analyze it with a computer, and you can store it with a computer and all the trappings of what a computer provides. There really are no cons. In the old days, the only disadvantage was the fact that these were very expensive chips. But nowadays, they're very, very inexpensive because technology has advanced. Now, what we're going to do is we're going to go to Lowell Observatory, where one of the most famous photographic plates was recorded, and that is the plate related to the discovery of Pluto. Let's have a look. So here we are at the famous Pluto telescope, and Kevin, can you tell us a little bit about it?
Yeah, we'd be glad to. This telescope goes back to really an idea that Percival Lowell had, that there is some ninth planet out there. And for years he searched for this planet. He never found it, but right before he died in 1916, he published an estimate of where he predicted it would be located. A decade later, the staff here at the observatory decided to start searching for this planet he thought was out there. And this telescope was brought in. The lenses were made by the same company that made the big Clark,
okay.
Alvin Clark and Sons, but the structure itself was made in-house. And it reminds us of the Clark telescope, but it's a lot smaller. Mm-hmm. But there's also something else a little bit odd. It has the tube, but there's no eyepiece to look through. That's because this type of telescope is called an astrograph, okay. And it's used, instead of looking through an eyepiece, to take pictures. And the way they would do it is, you see this big metal box-shaped thing here. This thing slides in and out. And so what they would do is go into a dark room and load a big photographic glass plate that has emulsion on one side. So it's like a big piece of film.
Okay.
And they would put that big piece of film in here in the dark, load it in that box, and then bring it up, slide it into the end of the telescope. So instead of having an eyepiece, you have this piece of film that's going to capture the image.
Okay.
And then what you would do is open the dome, point the telescope wherever you want to point it using the declination and right ascension wheel, so you know exactly where you're pointed. And you would take a picture of about an hour.
Okay.
And so you'd open the lens cap, and it would point in space for an hour.
Okay.
And then at the end of the hour, you would close this back up, take it back downstairs, and develop it. And then a few days later, you would come back and take a picture of the exact same area, and then put those two nearly identical pictures on a machine called a blink comparator. Okay. And look at every single dot from one to the other to see if it's changed position.
So looking for anything that's moving from one.
Exactly. So something the distant stars relative to each other are going to be in about the same position over a few days, but something really close to us, like a planet, is going to change position.
Okay. Well, what size of an area of the sky is this going to photograph?
It's about the size of your fist, arm's length, so 15 degrees or so.
Okay.
And so they systematically moved across a big swath of the sky searching for this.
In the area that they thought they might find this ninth planet.
So within a few months, Clyde Tombaugh discovered Pluto, and then for 14 years, he did the same thing, day after day, night after night, and searched about 90% of the sky in case there were other planets out there. He didn't find any others, but he did discover a lot of other things.
Oh, it's quite interesting. Well, thank you.
You're welcome.
All right, so here we are in the plate room where all of the photographic plates that are taken with the telescopes are stored, and Kevin is going to do something very special for us. He's going to show us the Pluto discovery plate, at least the envelope that's covering the plate. Kevin, can you tell us a little bit about it?
Sure. As we talked about in the Pluto telescope dome, what Clyde Tombaugh would do is take a glass plate this size, there's one inside of this envelope, and it has emulsion on it. He would capture a picture, and then it's like one big piece of film, one big picture. He would develop it, and then there would be a pair to this that he took a few days later. So this is one of the plates he used to make the discovery. Okay. The amount of sky that's captured on this is about the width of your fist at arm's length. So you can imagine how many images it would have taken to cover the whole sky. And so after Clyde was done developing one of these, he'd go a few days later, capture an image on another plate, develop that, and then put both of these side by side on a machine called a blink comparator. Okay. And you look through a little microscope eyepiece at a small section of one of the plates, then you flip a switch and it moves over to a small section of the other plate. Okay. And what you're doing is comparing the same field of view and looking at all those dots, most of which are stars.
Right.
And out of maybe 200,000 or 300,000 on the whole plate, you're looking at every single one to see if any have changed position.
Okay.
And if it has, it might be a planet. It's going to be something that's closer to us and appears to be moving faster relative to those background stars.
And can you tell us a little bit about the effort that Clyde had to put into to ultimately come up with the discovery?
Sure. When he did this, this was one of hundreds of plates that he took pictures of and analyzed. So he would put these on the blink comparator and look through that eyepiece and systematically, hours at a time, look through that eyepiece, look at the field of view, note every little dot from one to the other, and then change the field of view a little bit, and then compare everything in that. And so it would take him about a week to cover one set of plates to look at it. So on February 18th, 1930, about 4 o'clock in the afternoon, this was one of the plates he had in the blink comparator machine. The other plate he had is now on display at the Smithsonian Air and Space Museum. And so he had those 2 plates, and he was looking through the eyepiece and detected one of those points of light, or one of those points that appeared to change position.
Mm-hmm.
He measured the distance that changed over those few days' time and realized the amount that changed was proportional to what he expected something close to us, like a planet. And so at 4 o'clock, he realizes this. He calls to one of his colleagues to come and take a look. He looks at it and realizes it could be a planet. The next thing I did was go down to the director's office, and Clyde said, excuse me, Mr. Slifer, I think I found your planet X.
Oh, nice.
And Mr. Slifer, VM Slifer, said, okay, don't tell anybody. Let's do some more measurements to make sure that this is what it really is, a planet. And so whenever they took these big plates, they also had a secondary telescope with a 5-inch telescope. Mm-hmm. So they looked at that secondary plate to confirm what they had, because a lot of times they would find these dots that changed position, but it was a piece of dust.
Sure.
A variable star that was really bright. The next day you couldn't see it, but they found it on the backup plates.
Okay.
And so then Tomvaugh's job, he was told, okay, tonight, now that we've found the location of this thing, let's go to the big Clark telescope.
Okay.
We can get a good image of it through the telescope tonight.
Okay.
And so Clyde Tombaugh is still light. He's trying to figure out what to do. He's a little anxious, so he walked downtown, had some dinner, picked up the mail, and it's cloudy.
Oh,
and he couldn't view through it, and he couldn't go to the Clark telescope.
Oh, wow.
So he went to see a movie, Gary Cooper movie in the Virginian, and he kept jumping outside to see if it cleared up, and he didn't. So he had to wait till another night till he could get on the big telescope, capture an image with that, because now he knew where to look.
Sure.
And they studied it for several weeks. And then by March, on what would have been Percival Lowell's 75th birthday, March 13th, they decided to announce to the world, yes, indeed, we do have a new planet.
Oh, interesting. Now, it looks like there's some interesting things written on the plate. Can you tell us a little bit about that?
Yeah, see, you notice there's this yellowed portion here and then the white border. If I turn this around very carefully, this white border is a more modern acid-free envelope.
Okay.
The original envelope is this yellowish thing, and we've just taped the old envelope to the new one.
Okay.
Because this every time you do a photographic plate, you want to record the time, the exposure, all the weather conditions, so that you can recreate what you did.
Okay.
There's no point of doing it, just like anything in science, you have to record the data where you found something, or else you can't find it again.
Reproducible.
So exactly. So you have a lot of the basic information up here, the telescope used, the time you took the plate, and then this has a lot more information than usual, because after the fact, Clyde Tombaugh wrote this stuff on here because this is sort of his account of the actual discovery.
Oh, nice.
And then at the bottom, which was typical of all the envelopes, he noted what else he discovered on the plate. So on here, he found 8 asteroids, 7 variable stars, 12 temporary objects, no comets, and oh, by the way, Planet X at last found.
Oh, very nice.
Which
and it looks like a symbol for Pluto ultimately added there.
And we can tell that this was written after the fact because Pluto didn't get its name till a few months after the discovery.
Very nice.
So this is a really, it truly is a one-of-a-kind thing. That's why I have the white gloves and I'm holding it very carefully.
Yes. Well, this has been quite a treat, and I want to thank you very much for allowing us to come to Lowell Observatory and see some of these famous telescopes and help our students understand the nature of the telescopes, especially the history of the observatory. So again, thanks very much, and we hope you join us again. So as you can see, that was truly an amazing discovery. In the next video, we're going to continue our discussion of how light gets recorded and analyzed by astronomers. I hope you'll join me.